In this video, we'll see how bitwise operators can be used in Python programming language. One thing we should always remember that bitwise operators are applicable only to integers. And let us see, there are 4 bitwise operators. Bitwise OR, the symbol used is vertical bar. Bitwise AND, symbol used is ampersand. Bitwise NOT, symbol used is this tilde sign. Okay, and bitwise exclusive or sometimes we call it XOR. The symbol is this. Let us see the truth table of each one of them. Most of you may be knowing it. This is bitwise OR. So point to be noted is if any of the inputs is 1, output is going to be 1. This is the property of bitwise OR. Here I have assumed that the size of a number or maybe integer is 16 bits only. So least significant bit has been numbered as 0, whereas the most significant bit has been numbered as 15. So 0 through 15, total 16 bits. For example, if x is equal to 30,000, its bit representation would be this one. Okay. If y is 31,237, its bit representation is this one. Now, if we take the bitwise OR, so here it is 1, so result would be 1. Here both the inputs are 0, so output would be 0. Here both the inputs are 1, so output is 1. So likewise, you can find out and you can verify that the bitwise OR of x and y in this case would be 32,565. Now bitwise AND. So pay attention here. If any of the inputs is 0, output is going to be 0. Again, same example, 30,000. This is the bit representation. This is 31,236. This is the representation. And bitwise AND results in this. You can see here, this is 0. So output is going to be 0. Here, this is 1, this is 1, so output is 1. Likewise, you can verify that the bitwise AND of 30,000 and 31,237 is 28,672. Simple. Next is bitwise NOT. This is a bit interesting. If this is unary operator, so it requires only one operand. So it has been applied only on x, that is the only input applied to bitwise NOT operator. So if input is 0, output is 1, that is the flipped bit. If input is 1, output is 0. Here, for sake of explanation, I have taken the result, obtained the result or written the result by assuming that there is no 2's complement, nothing else. So this 0 becomes 1, this 0 becomes 1, and these 1's become 0. Accordingly, you can make out that this value, this bit pattern here represents 35,535. But remember, in most computers, negative numbers are represented as 2's complement. So whenever a most significant bit is 1, the number is treated as negative. And that is why when this operator is used in programming languages, the result is not same as it appears here. Okay, so that will be clear with an example. And the last one is bitwise exclusive OR. So here, whenever the inputs are dissimilar, output is going to be 1. So here both the inputs are different, output is 1. Here also both the inputs are different, output is 1. Whereas in the first row, output is 0 as well as in the last row. So now let us see through an example, try to understand. I have already written a script written in the right pane. So usual shebang line, and you can read two values at the key from the keyboard using input function. and this can be prompt. And remember, in one of the videos I have already told that whatever you type, it is just treated as a string in Python programming language. So the split function normally I use, what does it do? It tokenizes the input stream, and this function int converts the string representation into numerical value, that is x here. So same variable I am using here. So now onwards, y would be treated as an integer. Why integer? Because we know that all the bitwise operators are applied only to integers. So now let me execute it. Now it is asking me to type into integers. Type in two integers. This is the prompt. So now suppose I supply two inputs, 5 space 10. Now the first print, okay, gives this result. That is bitwise OR. Second print gives bitwise AND. So you can find out, you can verify that the bit representation of 5 and has the bit positions 1 in bit positions which are not there in 10, and that is why x and y is 0. Third one is this one, bitwise exclusive OR. So the result happens to be 15. You can verify. And the last one is interesting. Here, since it is a unary operator, so only one is required. So suppose I have chosen this x. So bitwise not of x is -6. Because what happens is, whenever you take bitwise not, zeros become 1 and ones become 0. So most significant bit is 0. Its bitwise not would be 1. So number would be treated as negative. And all negative numbers in computers are represented using 2's complement form. What is 2's complement form? Take 1's complement, that is flip each bit 0 to 1, 1 to 0, and add 1. I have written one more script. Yeah. So if I type 5, what does it do? It says there are two ones, and Python processes negative numbers slightly different than C and C++. So here it does not print all those leading zeros as is done in C and C++, because their size of integer is fixed under the implementation. Whereas, as I told you in previous videos, that the number of digits which can be used as in Python to represent integer is practically infinite. So if it is 5, it will print only 101, no leading zeros. So if I rerun it and if I say -6, it will be represented as -110. So Python processes and represents negative numbers in different way, and their bit patterns also. So let me rerun this. This time let me type 5 and 6 again. So pay attention to the last one. This is x equal to 5. Bitwise not of x is -6. And if I rerun with -5 and 6, suppose, so now you can see it has given 4. So the last one. So the point to be noted is, if number given is integer given is positive, so bitwise not will result in a negative number whose absolute value is 1 more than the input value. Similarly, if the input applied itself is -5, then its bitwise not would give you a value which is positive in sign and 1 less than the input in magnitude. Okay, so that is all in this video. Thank you.